Okay, welcome to the first Common Core Algebra 2 review sheet. Your first exam is going to be on Thursday, October 6th for period 8-9 and Friday, October 7th for period 1-2. Right now it is September 30th, so that gives you plenty of time to practice and learn how to do these 10 different types of problems over the next week or so. Let's get into it.
Mr. Rose, if he's still in the building, please call extension 5047. Mr. Rose, extension 5047.
Well, that was kind of annoying. Anyway, number one, which graph has the following characteristics? 3 real zeros. Well, this one's got 1, 2, 3. That checks out. This one's got 1, 2, 3. That checks out. This one has 1, 2, 3. That checks out. This one has 1, 2, 3. That checks out. As x approaches negative infinity is left. F of x approaches negative infinity, that's down. As this one goes to the left, this is going up. That's approaching positive infinity, not going to be it. This one also is going up to positive infinity. That's not going to be it. This one is going down to negative infinity. That one checks out. This one is going down to negative infinity. That one checks out. Last stipulation. As x approaches positive infinity is to the right. F of x approaches positive infinity. That's up. As it goes to the right, this one goes up. As it goes to the right, this one goes down. That does not work. Choice 3 is the only one that satisfies all three. This is your notation for end behavior. Make sure you're familiar with how to notate your end behavior. Let's move on to the next one. To find the zeros, replace f of x with 0 and solve a polynomial equation. To solve a polynomial equation, we must factor. First thing we look for when factoring, GCF. There is a GCF. So I put the GCF outside of one set of parentheses. And now I can ask myself, can I factor any further? Well, there are 4 terms. 4 terms have got to be grouping. So I group the first set, the second set. I'm going to ignore the x for now, that's outside. I'm just going to leave it for now. I can take out x squared. X squared, x minus 4. I can take out a negative 9, minus 9, x minus 4. I combine my coefficients, I keep my like term, and my x comes down with it. Can I factor further? Yep. Difference of 2 squares. That's going on here. X squared minus 9 becomes x plus 3x minus 3. And now that I'm factored completely, I have 1, 2, 3, 4 factors, which I should, because it should match the degree of the polynomial. I set each factor equal to 0. X equals 0. X plus 3 equals 0. X minus 3 equals 0. X minus 4 equals 0. Minus 3, plus 3, plus 3, plus 4, plus 4. I have x equals 0, x equals negative 3, x equals positive 3, x equals positive 4. Looks like my answer is choice number 1. Right off the bat, since it had a power of 4, I knew that it can't be choice 4 or choice 2 because there's only 3 answers in each. All right, let's move on to the next one. Division. To divide polynomials, we're going to use long division. Now, because there's no x squared term, I have to put 0x squared to hold the place. When you're doing long division, divide, multiply, subtract. When you're subtracting, you keep, change, change, and then you're bringing down. That's one full cycle. Do as many cycles as you need to until you finish. So what am I dividing? I'm dividing the first term by the first term. That's 2x squared, and I'm putting it over the x squared term. That's divide. Multiply. I'm multiplying the 2x squared times the 2x plus 3. It gives me 4x to the third plus 6x squared. Subtract. Keep, change, change. Cancel. Negative 6x squared plus 5x. Bring down. That's one cycle. Next cycle. Divide. Negative 6x squared by 2x. That's negative 3x. Multiply. Negative 6x squared minus 9x. Subtract. Keep, change, change. Cancels. 14x. Bring down. Next cycle. Divide. 14x divided by 2x is 7. Multiply. 14x plus 21. Subtract. Keep, change, change. Nothing left to bring down. So if I have a remainder of 11, I put minus 11 over the divisor, which is 2x plus 3. Looks like my answer is choice 2. You don't have to do your long division. If you do, you'll get it right. There's a study done on oxygen consumption of snails with a function of pH, and the result was a degree 4 polynomial function whose graph is shown below. Fantastic. Which statement about this function is incorrect? The degree is even. Well, because it ends pointing in the same direction, it's U-shaped, yes, it's even. If it's chair-shaped, if it opens and closes in different directions, it's odd. There's a positive leading coefficient. If there's a positive leading coefficient, it's going to slope up at the end. This is sloping down at the end, so it must have a negative leading coefficient. That can't be true. At 2 pH values, there's a relative maximum value. That's a relative max. That's a relative max. So that's true. There are 2 intervals where the function is decreasing. Let's go through it. These graphs are like riding a roller coaster. At the beginning, I'm going up. It's increasing, going up and going up and going up until I get here. Now I'm going down the roller coaster until I get here. Now I'm going up the roller coaster until I get here. And then I'm going all the way down forever and ever. So my green is where it's increasing, my red is where it's decreasing. How many intervals is it decreasing? There's 2 reds. So yes, that's true. Which one's not? Choice 2. We talked a lot about polynomial graphs. Make sure you know all the information from the completely factored form. Factoring, again, let's write this out so I have more space to work. First thing, when you're factoring is a GCF. Is there a GCF? Yes. 2D. D squared plus, c to the third plus 3d squared minus 9d minus 27. Can I factor further? Well, there's 4 terms, so that's going to be grouping. I got d squared. I got negative 9. So I got, again, I'm going to ignore the 2d just like the other problem I did. We got d squared, d plus 3, minus 9, d plus 3, which is d squared minus 9, d plus 3. And let's bring that 2d down. Can I factor further? Yep, I got dots there. So I'm going to have not enough space to do this. 2d, d plus 3, d minus 3, d plus 3. Works. Because I have 2d plus 3's, I can rewrite that as d plus 3 squared answer is choice 3. Determine if x minus 5 is a factor of 2x to the third minus 4x squared minus 7x minus 10. Explain your answer. There's two ways to do this. It's a factor if it divides evenly. So the first method, long division. It's a factor if it divides evenly. All right, let's do this. First divided by the first. 2x to the third divided by x is 2x squared. Multiply 2x to the third minus 10x squared. Subtract. Keep, change. Cancel 6x squared. Bring down. Divide. 6x. Multiply 6x squared minus 30x. Subtract. Keep, change. 23x. Bring down. Divide. Multiply. 23x minus 115. Subtract. Keep, change. Cancels. 105. Nothing left to bring down. So we have plus 105 over x minus 5. Does it divide evenly? No. It does not divide evenly. When it says explain your answer, you better explain your answer. The other method is a remainder theory. It divides evenly. If it's a factor, it divides evenly. If it divides evenly, it has a remainder of 0. So I do p of 5, and this will give me the remainder when I would have divided it by x minus 5. A little cramped, but not a problem. I can put that into the calculator. It's going to give me, well, I know what it's going to give me. It's going to give me 105. So literally just type this into the calculator, it gives you 105. So because there's a remainder of 105, no, because there is a remainder of 105. If it was a factor, it would have a remainder of 0. All right. What is the remainder when p of x is divided by x plus 4? This is the same thing we just talked about. If it has a factor of x plus 4, that means it's going to have a 0 at negative 4. Does the thing have a 0 at negative 4? Yes. That means that it's a factor. If x plus 4 is a factor, if I divide it by a factor, it's going to give me no remainder. Same concept that we just talked about. If negative 4 is a 0, then x plus 4 would have to divide them evenly. If it divides them evenly, it has a remainder of 0. Conceptual question. I'm not going to read this thing out loud. You can read it to yourself. What is the maximum value? No, I'm going to read it. For a fundraiser, members of the math club decided to make and sell Pythagoras. May have been for Matt's first problem, but not his last. T-shirts. Lame math club student to do that. What can I say? They are trying to decide how many T-shirts to make and sell at a fixed price. They surveyed the level of interest of students around school and made a scatter plot of the number of T-shirts sold versus profit shown below. So my x-axis is my T-shirts sold, and my y-axis is my profit. So it says, what is the maximum value? Well, the maximum value, if I sketch the curve here, is right around here. It's approximate. The maximum value is the y value. The point itself is approximately 35, 300, which means the maximum profit is $300. What does it mean in the context of the problem? It means that the most potential profit they will make is $300 if they sell 35. They love to say in the context of the problem, so just make sure it makes sense with what the problem is talking about. Find algebraically the zeros for P of X equals. Okay, I think we already did that. Something similar. To find the zeros, algebraically, I replace the P of X with 0. And I factor. Is there a GCF? No. There's 4 terms, so it's got to be grouping. X squared, x plus 1, negative 4, x plus 1, 0 equals x squared minus 4, x plus 1. Can I factor further? I sure can. That's the difference of 2 squares. X factor equal to 0, x plus 2 equals 0, x minus 2 equals 0, x plus 1 equals 0, x equals negative 2, x equals positive 2, x equals negative 1. That's the answer to the first part of the problem. Now it wants me to graph it. To graph it, I need the zeros, which I just found. I got negative 2, I got positive 2, I've got negative 1. I need my y-intercepts. My y-intercept is the constant term, that's negative 4. I need my little picture, I need my end behavior. Starting with the degree. I have an odd degree with a positive coefficient. Know your 4 little pictures. It's got to look something like that. Do I have any double roots? No, I have no double roots. They're all different. So I'm going to pass through the x-axis, and I'm going to start by sketching my little picture. I'm going to start like this. It's going to pass through. It's got to turn around at a certain point. It's got to pass through. It's got to turn around at a certain point. It's got to pass through. And it's going to look something like that. Again, this is just a sketch. I don't need to find the actual local mins and local maxes. That's it. What else do I got? Mr. Farrison gave his class the 3 mathematical rules shown below to either prove or disprove which rules can be proved for all real numbers. Well, I know my binomial squared theorem. A plus b squared equals a squared plus 2ab plus b squared. So, let's try the first one. Well, the first one doesn't even try. It holds true. There is no rule for to the 3rd power. So, I could start multiplying it all out, but I have no reason to believe that's going to be the case. And now, again, I have a binomial squared. It's a little more complicated, though. So again, I know I have my formula here. So let's see if I have enough space here. Let's do a squared plus b squared squared. So that means that a is a squared and b is b squared. So a squared squared is a to the 4th plus 2ab is a squared b squared plus b squared squared is b to the fourth. Now I need to see if it's equal to the right-hand side. So for a squared minus b squared squared, again, a is a squared and b is b squared. A squared squared is a to the fourth minus 2ab is a squared b squared. B squared squared is b to the fourth. But to that, I want to add 2ab squared, which is going to give me a to the fourth minus 2a squared b squared plus b to the fourth plus 4a squared b squared. When I combine like terms, negative 2a squared b squared plus 4a squared b squared is positive 2a squared b squared plus b to the fourth. This is the same as this. So it holds true. 1 is true, 3 is true, and 4 is the answer. It gets a little messy with the algebra, but this question has to do with your binomial squared theorem. That's it. 10 questions. You know how to do 10 questions, you're going to ace this test. You don't put any time in, you don't practice it, you don't watch this video, you might not do too well in your first exam. If you're taking the first step, if you're watching this, if you're hearing me right now, it's not just watching this that's going to do it for you. You need to practice. You have plenty of worksheets, plenty of examples to practice. Study with a friend, come to a tutorial next week, do what you got to do. But that is it for me. Hope you enjoyed. It's not a question of ours. That's it. Just want to turn this thing off. Hopefully it works. 22 minutes, not bad. Goodbye. Bye.